In the previous video, we tried two different methods of using 3D printing to make casting metal easier and with better results. One of them failed horribly, the other one was better than I expected. We compared them against a very basic lost foam casting as well. And today we're going to see if we can get perfect results on an even larger and more complex model by making some very small improvements to the mold. And we're also going to level up our lost foam method so we can compare a better mold against a better lost foam to see which one is the best. So let's get those made and start pouring some metal. Probably the fastest and easiest way to cast is by using the lost foam method, and it worked well when we tried it. The casting does not look very good, but it is solid and there is no visible porosity. I used standard white polystyrene, which is made from beads from expanded foam last time. But it didn't cut very well on my CNC because it melted so easily, and it doesn't have a very fine grain structure inside to preserve the details. Before we go too far, I'd like to try to understand what's happening when we pour molten metal into the mold. So I added some blue food coloring, which did not agree with the hot wax that I was using, and I also added in some of Steve Spangler's radioscopic fluid, so hopefully we can actually see the flow a little bit better. This is most important with the 3D printed mold being converted to a plaster and sand mold, because we need to have a place for the gases, whether they are water vapor or heated air, to easily escape. Originally, I designed the mold to have the casting sitting vertically, and we had this area up top which was not vented very well. And so when we poured the molten metal in there, that area could not fill completely because there were those gases trapped inside. This is basically the same design, except I added a blind riser, which helps to feed the cooling part because it has enough volume to cool more slowly. The beauty of pouring hot wax is that it cools quickly and shrinks quite a bit as well, just like aluminum would, so it should do a pretty good job of showing us what we should see with a metal pour. For this pour, we can see that there isn't a smooth transition into the sprue leading down into the casting, and rather than the sprue filling, it leaves a pocket of air trapped in there. And you can see just at the very end when it fills, that bubble manages to make its way up and escape. What's interesting is that the pour produces this kind of segmented look. It looks like it raises up incrementally rather than continuously. As the top starts to solidify enough, it requires some additional pressure to force that top up, and it's moving up little by little. The blind riser seems to fill just fine, and we can also see that the core in the center of the cylinder acts as kind of a separator for the stream of hot wax as it comes in. I noticed that the step down or step up in the central shaft did not form perfectly crisp, and at the very top there were some small trapped bubbles, though this mold did fill completely, unlike the one from my last video. Now we can test an improved version on a more complex shape. This one has more of the features of a professional mold, and you might have noticed that we've changed the orientation as well. We have the cylinder in here horizontally in the mold with the vent at the very top, which should mean that we're not going to have any of those trapped gases in there like we did last time. It has a convex shape on the outside, and also I've added these recesses because I need to reduce the amount of material for the pour. My max pour is 3 kilograms or 6.6 pounds. And I want to make sure I can fill the entire mold without having any trouble. The seam between the two halves should also act as a kind of a vent. We saw from the previous video that worked well with the aluminum. It formed really nice and clean around that seam. So turning the casting horizontal should allow the entire casting to vent a little bit better. It has a much better pouring basin. It has slightly filleted corners, but the most important thing is that we have only 6 millimeters from the bottom of the transition to the entry into the sprue. This also has a blind riser or a feeder, so as the metal cools, this area is much larger and it's contained well enough to cool last, and it should feed into the casting near the bottom and keep it from shrinking too much. This has an exposed riser which will also act as a vent, and I positioned it right at the top dead center where the gases naturally collect so that they can escape. The gate from the blind riser to the part is also slightly larger, so it does not cool as quickly, and that can hopefully keep it feeding well. The hot wax here is flowing much better this time, but the sprue is not filling, which I think is probably because I'm trying really hard to aim this and I'm pouring kind of slowly. The riser is pretty large and it seems to be filling well. It should vent okay thanks to the seam between the mold parts. And initially the hot wax flows down, and then as the mold fills, the flow is disrupted by those recesses that we added in. We still have that kind of segmented look, which indicates that pressure buildup to force the wax higher rather than a complete mixing of melted wax. The open riser and the vent combo at the top fill well and should act as a place for the casting to draw from as it cools as well. Overall, it performed really well, but what I did not expect in both of these tests is that as the wax was cooler on the top, it required this pressure buildup to continue to fill the mold rather than staying completely melted and mixing like you'd see with something more like water. So I'd expect that the metal at the top of the mold is going to be a fair amount cooler than the metal at the bottom where it's closer to entering. So it looks like this is going to work for us, so let's get the plaster into our 3D printed mold, and this time I have removable sides and the pattern should come out a little bit easier thanks to those draft angles. So the last time we mixed up plaster Paris, we mixed up sand and a bit of water, and that was pretty much it. I put it into the molds. The molds did not have the appropriate draft angles, so I needed to heat the PLA to be able to extract it. Instead, this time I've actually created the molds properly with draft angles, and the shell or the wall around the outside can come completely away from that. And I have one special ingredient that's going to help to reinforce the plaster as well, kind of like what you'd see in concrete where you have rebar or you have these small steel pieces or small fiberglass pieces that help to reinforce it from cracking. I'd like to try that in the plaster Paris as well. This one here is just basic plaster Paris made by DAP. Very easy to work with and pretty cheap as well. I'm going to add a bit more sand than last time as well. Kind of act as an aggregate. It is an aggregate, but similar to what you have in concrete. I'm not going to mix in my special ingredient just yet. I'm going to mix the water in here, get a nice kind of slurry, and then make sure I have a nice smooth bubble-free layer at the bottom, and I'll use the paintbrush to dab that around. I'm going to try and do both molds as well at the same time here. Hopefully I'm good enough at it. This is beard hair. Don't ask me why I've been collecting beard hair. And I think this will do a great job of acting as kind of a reinforcement for this. To compare, like last time, I've made a version from the foam, but this time I've used the XPS pink foam insulation, so hopefully we will capture more detail. So we're just about ready to pour. I have some metal that's heating up, outside right now. I'm going to preheat these again, but they are already dry. I'm going to crank up the heat a little bit more than I did in the last video because I think that's going to help for the metal to continue to flow better into this mold. I'm going to preheat these graphite molds as well for any excess that we have. Unfortunately, I was not able to salvage my PLA forms. You can see there I had to heat them up to get them out. They became just flexible enough for me to extract them. This one was much more difficult. And machining the pink styrofoam, or any styrofoam for that matter, is not easy on a CNC machine. Unfortunately, the heat buildup really causes this material to melt at a low temperature. So to solve that problem, we need to turn the feed speed way up. I've doubled the feed speed, and I also turned the router down to about 3,000 RPM. Normally it's running around 18,000 RPM or so. And that seemed to do an okay job. It's not absolute perfection, but it is good enough for what we need to do. So for the aluminum for our castings today, I want to be using material that I melted down from other castings. So for example, this is the impeller blade from my dust collector. It was broken. Somebody tried to get it off of the dust collector with a big hammer, and they broke it everywhere. You can see some fractures, some cracks. This was extremely difficult to break these pieces off, so it is really durable. And that produced castings that look like this. So kind of a dull surface finish, a little bit of a depression in the center there. I melted down some aluminum wire to compare, and this is what it produced. So a completely different surface finish. You can see very shiny in comparison to the casting material. And also we have this huge depression in the center, kind of indicating that this material shrinks quite a bit more when it's cooling. So I don't want to use what I melted down from wire. I want to use what we had from castings because that's what it's intended for. So it should work well to give us the best chance of success on our castings. And we're ready. Let's pour. So we lost a little bit of metal up on the top here. And unfortunately, it looks like we ran short. We'll have to see how that turned out. Got a blizzard going on here. All right, let's give it a try. Recording. Lots of metal this time. Oh shoot, get the camera. Just gotta try and keep that basin nice and full. Should come right up the top. Hopefully. Oh yes. And a little bit to spare. Whew. Just a tiny bit of bubbling, but nothing close to what I had the last time. I think because I did a better job of drying this mold out. So I filled up the crucible completely this time. I wanted to make sure I had enough, and I had just enough, a little bit extra. And you can see the last time I did this, I didn't have the metal coming right up the riser. The riser was a little bit too small. The open riser, or the vent I should say, This time, because it was a little bit larger, I think it could retain its heat a bit better and it was able to come right up. So that's a really good sign as well. Very little bubbling, so that's also a really good indication. And the pour went relatively well. I think just a matter of trying to get it started was the most difficult part. So I'm gonna let this cool for a little while and then we'll come back and open it up. Oh, almost. That's too bad. So this is still hot, but it's been about a half an hour. Let's see if we can, oh yes, yes, yes. Oh no, no. So close. So close, but look. Shoot. So lost foam, I had fail after fail after fail after probably the worst fail. I was trying to pour this one late at night. I tried a little bit different methods each time, and really it all came back to the fact that I'm trying to save material here. And I've got all these hollows in here because I don't have a crucible that's large enough to do a pour that's this big. So I adjusted the sprue, for example, coming down because that was eating up some material. Well, that caused a problem. And then we had this section here, and aluminum forms this oxide layer, so when it comes up, if it comes up unevenly into here, it cannot connect or merge completely with itself, forming a cold shut. So this would require quite a bit of work to fix this. It really isn't usable. And that is pretty much why the original one that I did in the last video I think worked out fairly well. It's quite beefy, it's very simple, there's no webbing going on. Now if we take a look at the plaster version, it's not perfect because we didn't get the connection at the top, but the issues are the exact same. We did not have enough material. I was trying to save material in here, and because of that we had two problems. One was we had this area cooling too quickly. So it found its way up the riser, up the vent, much more easily than completing this section because it had cooled too much by that point. We also had a little bit of a cold shut in here too, so we had an oxide layer forming here and here. As it tried to merge, it could not merge completely. So again, the failure in this one relates to the fact that I don't have enough material to pour a piece that's this big unless I do this ribbing, and with the ribbing it really just does not work very well. Now I could try and make this work, but I think the best solution really is to find a way to melt more metal, adjust the sizes of everything to be a little bit larger, and instead of having this ribbing in here, it's just going to be completely solid, and if I wanted to remove this later, I can do that at the CNC machine. If we take it out to have a look at the backside, you can see that it formed much better. Not perfect, there's still a little bit of material at the top here, so it was a bit starved for material. I think that this riser slash vent needed to be larger. It's better than the last time, but still not perfect. And at the bottom you can see that very similar effect to what we were seeing with the hot wax. So normally I keep on trying again and again until I finally have success, but in this particular case, I think the casting equipment that I have is not large enough for the job that I want to do. There are some issues probably with the mold. I could probably make some little tweaks and improvements here, but it's a little bit risky and a little bit of a waste of time when really what I need to do is remove that detail and have a much beefier casting. And that goes for the 3D printed method and the lost foam method. Now what I will say about the lost foam is that I think the success rate for lost foam would go up if I coated it in refractory cement. but that requires it to be dried out for several days. It also requires me to buy that material. And at that point, I have to wonder, why would I do that when plaster of Paris is so cheap and I could just do it that way? And also the results with the plaster of Paris seem to be much cleaner when it comes out. Adding these little details into the mold really is not that good of an idea when it comes to casting aluminum. We have the issue of it cooling too quickly and the oxide layer forming as well and creating a cold shut, an area where it is weakened and it may not completely join with itself. I also want to mention I have some very interesting videos coming up soon. I also have a Kickstarter coming up, and I will be making a video on that subject very soon. Thank you to each of my patrons for helping to support this channel, and thank you for watching. Take care, and I hope to see you on the next one. That's strange.